That song came from a very famous television show back in the 1950s, I believe, early 60s, known as Peter Gunn. That song was written by Henry Mancini, the same composer of the famous Pink Panther theme song. All right, well, I'm going to get high-tech today, and we're going to learn how to use our TI calculator to crunch out some of these inverse trigonometric things here. So mainly what I'm going to do is just kind of show you, to begin with, how to do a few of these things on the calculator. And then I'll display this calculator kind of at the side so you can see what I'm doing here. Okay, so one of the first things that we want to do with this is we would like to enter, okay, like on this we're looking at, if I say sine of alpha equals 0.5869399, what you're really doing is you're looking for the angle alpha. So the way that you enter this in your calculator is you enter it as inverse sine of, and then you put that number 0.5863909 in and so forth like that, okay? And then you'll get an answer. So what I want to do is show you this TI emulator, and this will kind of show you exactly what you do. The first thing is, in this particular problem, one of the things that I said on here is I said that I wanted the answer to be in degrees. So I want the answer to be in the 10th of a degree. So that's why we're going to do this. So the first thing is we're going to press the mode button. And you want to get, if you go down to line 3, you want to be in degree mode. So you want to highlight that and press enter. Now you're in degree mode, so that's real important. Then you just do this like this. If you want the inverse sine button to come up, then you got to press the second button first, then the inverse sine like that. So I'm going to start this like this, second sine. Then I put in the value that I'm interested in, which is 0.5863909. Close parentheses, and then that'll give the answer of the problem, okay? So that is about 35 point, and I want you to round this to a 10th of a degree, so that would be about 35.9, okay? So we'll go ahead and record that as 35.9 degrees then, just kind of rounding off to what I'm specifying. Okay, so that is going to be 35.9 degrees. Like that. And then we're going to do kind of the same thing on the rest of these things. And the rest of them I'm just going to do on the emulator and kind of show you how it goes. One thing I do want to show you on this is the last calculation on the TI 8384 type calculators is always stored under this memory key, the ANS as an answer. So I want to show you if I did the sine of ANS, what that's doing is it's doing the sine of our answer, 35.901311161. If I press enter, notice that it takes you back to where we started from. Okay. Now let's go on and let's do the cosine like this. So now you would go second cosine, and then you would put in 0.40997389, close parentheses. Then that would give you about, we'll just say that's about 65.8 then. Okay, so I'm going to go ahead and put that in and record that now as 65.8 degrees. Okay, now back on this emulator, what I want to show you again is if I do the cosine of the answer, because see the angle 65.79 is the answer, then it takes me back to where I start from. So that kind of helps you understand the correlation between inverse cosine and cosine, okay? Now what I'm going to do on the next problem is I'm going to go inverse tangent, then I'm going to go 2.0404315, close parentheses, press enter. That'll give the answer, so we're going to round that off to 63.9 degrees as an answer to that, okay? So that's how we get that. And again, I'll show you one more time on this because this kind of helps you understand the relationship, is if I did the tangent of the answer that I just got, then that would take me back to the beginning, like that. Okay, so I'm going to go ahead and just you can go ahead and pause right now if you want to and punch these in on your calculator and just see if you get the right answer. All right, well, let's see how we did then. I'll just put these in. You can see if you got the same answer I got. So if we do the inverse tangent of 1.9584898, okay, that's going to give 62.95. If we round that to a tenth of a decimal, you know, it's going to go like this. You have 62.95 now. So if I was to put in like this, if I was to put in the 62.95, and if you're rounding that to one decimal, well, that's got to go up. The 9 has to go up to 10, really. So you would just say on this 63.0 degrees, or just 63 degrees like that, okay? Then the next one, you should have done this. If you do, the way you put this in is you do inverse sine of 0.29066,515, and then that's going to give an answer of about 16.9 should be the answer that you came up with on that then, okay? So 16.9 degrees. Okay, so that's how you do that. It's a real simple thing to do. Now, the next thing we're going to do as I go to the next page is we're going to look at the definitions of the trig functions. And we've looked at x, y, r definitions, so we're going to look really at an angle now, so at a right triangle. So if you have an angle x, then the side opposite, on the opposite side of the triangle, we call that the side opposite. The side that's next to that angle that's not the hypotenuse is the adjacent. And then the hypotenuse, of course, is what we've learned before. So if you kind of look at this, I want to show you that these definitions aren't really anything new. The sine we learned is y over r. So it just says it's the hypotenuse, opposite over hypotenuse. So if you look at this diagram, that opposite's really the y value. The hypotenuse is really the r value. So you can think of it the same way. We learned also that the cosine was x over r. So that would be adjacent over hypotenuse. So if you look at this side adjacent in this triangle, that's x. So that's how that works. Again, it's nothing new. And then if you go to the tangent we learned was y over x. So it's opposite over adjacent. So notice if you do opposite, which is really like y, and adjacent's really like x, then you have that definition. And then, of course, everything else is the same. As we learned, the cosecant's the reciprocal of the sine, so that's going to be hypotenuse over opposite. The cosine and secant are reciprocals, and the tangent and cotangent are reciprocals like that. So you want to memorize these definitions. There's a couple of ways that that teachers teach this to help students remember this. One of the famous ways is Sohcahtoa, where S stands for sine, O stands for opposite, and then that stands for hypotenuse. So that says sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. That's the c. And then the tangent is the opposite over adjacent. Okay, so you can memorize it that way if you want to, and that's fine. Sometimes I teach it this way. Many years ago, I was curious about coming up with something, and I gave students a contest. I said, whoever comes up with the best mnemonic device to remember sine, cosine, tangent will get like an extra 100 points or something. So they came up with the sine, O over H, the cosine, A over H, and the tangent, O over A. So they came up with Oscar has a hairy old ass. So I thought that was pretty funny. And of course, there isn't anything nasty about that. All they're talking about is just like their pet donkey. Okay, that's not a very good donkey. But Oscar has a hairy old ass is a second way. You can learn that if you want to, okay? All right, so we're going to go down and look at some triangles, and we're going to do some basic things on this. So we're going to, on this example 16, we're going to just fill out the 6 trigonometric functions on this. So we're looking at and focusing on angle alpha. So the sine, by definition, is opposite over hypotenuse. So if you look at opposite that is going to be 28. Okay, and then the hypotenuse is going to be 35. That's the longest side of the triangle. And then you could go through and you could reduce that fraction. You can do that in your head if you want to, because what you're doing is just dividing by 7. So that would give you a ratio of 4/5. Okay, and since the cosecant is the reciprocal of the sine, then we can go ahead and automatically get those two trig functions. Okay, then we learned that the cosine was x over r, but now we're looking more at adjacent over hypotenuse. So if you were to go through and look at that angle now, and I'm going to just erase this mess I've made here on this triangle, and then we can kind of start over again. So if I look at this, if I look at angle theta again, now the side adjacent is this. The hypotenuse is 35. So what we'd end up having over here is we would have 21 over 35. And then again, you could just reduce that fraction by a value of 7. So you would get 3 over 5. And then the secant is the reciprocal of the cosine, so that's going to give a value of 5/3. Okay. Then the tangent's definition in a right triangle is opposite over hypotenuse. So let me erase this and start over again with this. So if we look again and focus in on that angle alpha, and you're looking at that alpha, then the side opposite is going to be opposite that angle, so it's that. And the side adjacent is the side next to it, so that means the tangent is going to be 28 over 21. We can reduce that fraction by 7. So we end up on that getting a value of 4 over 3. And then the cotangent is the reciprocal of the tangent, so we've got that ratio figured out. So it's really not any different than XYR definitions. So you want to get those committed to memory. Sohcahtoa, Oscar has a hairy old ass, or convince something yourself. Take your pick. I could care less. Okay, now on the next page, I'm going to do one more like this and just kind of make sure that you got the hang of this then. So, all right, the sine is the opposite over hypotenuse. So we're looking at this angle alpha, opposite's 20, hypotenuse is 52. So we're going to do 20 over 52. That fraction reduces by 4, I believe. So you'll find that 20 divided by 4 is 5. 52 divided by 4 is 13. And then once we have the sine, the cosecant is going to be that reciprocal like that. Okay, the cosine is adjacent over hypotenuse. So again, if you look in at this angle, the adjacent, I don't know why it does that. Let me erase that. So if I erase all this stuff right here, and then let's just kind of go through and figure out what that is. Again, what you're doing is you're looking at the side, the angle. The side adjacent is this. The hypotenuse is 52. So you'd end up having 48 over 52. And then you can reduce that, I think, also by 4. So if you divide both of those by 4, you're going to get 12 out of 13. So the cosine ratio is 12 out of 13. That means the secant is going to be 13 over 12. And then the tangent is going to be opposite over adjacent. So if you look at this result, okay, the opposite of that is 20. The adjacent is the side next to it that's not the hypotenuse, so that's going to be 48. Okay, again, it looks like you can divide by 4 to reduce that fraction. So it looks like you're going to get 5 over 12. So the tangent's 5/12. That means the cotangent must be 12/5 like that. So you want to write those ratios based on your knowledge of those definitions. Now what I'm going to go ahead and do now is we're going to go ahead and pause this video, and you can go ahead and work the next one out. Be sure that you reduce the fractions on number 18. All right, so let's see how we did on this then. Okay, so the sine is opposite over hypotenuse. If you look at that angle, okay, the side opposite is 10. The hypotenuse is the longest side of the triangle, so that is 26. Okay, reduce the fraction. Looks like these both divide by 2, so you should have come up with 5 over 13. The cosecant is the reciprocal of that, so that would be 13 over 5. Okay, the cosine is adjacent over hypotenuse. So if you look at this angle alpha, the adjacent is 24. The hypotenuse is 26. Again, you can reduce that by 2. So you'll get 12 over 13 is going to be your answer to that problem. And then the secant just reciprocates to 13 over 2, like that. Okay, the tangent is opposite over hypotenuse. So opposite that angle is going to be 10. Adjacent's 24. So if you divided that by 2 to reduce the fraction, you should have come up with 5/12. Then the cotangent is the reciprocal. So you should have come up with 12/5 like that. Okay, so that's the first stage, is you want to know how to take a right triangle, just write the ratio. Now what we're going to do is we're going to learn how to solve parts of a right triangle then. Okay, so one of the important things as we go through this next problem is I'm going to go through and draw a right triangle. And what I'm going to do on this is just show you kind of what I consider to be the naming convention. Now, I'm not going to bother to draw this thing to scale or anything because it doesn't really make any difference. So let's just get us a pretty good right triangle drawn right there. And the way this goes is there is a naming convention that you have to be pretty solid with. And it goes like this. Okay, typically one of these acute angles is alpha. The other one's beta. That's the way our textbook does. And then the right angle, we use gamma. So we're just using the first 3 letters of the Greek alphabet, alpha, beta, and gamma. And gamma is always going to stand for the right angle. Alpha and beta are going to be the other 2 angles. Then it goes like this. The side opposite alpha, we use lowercase a. The side opposite beta, we use lowercase b. And then the side opposite gamma, we use c, like that. So what I'm going to do is let's write down what I gave you. In this particular problem, I gave you that side A is equal to 13.2, and I gave you that side B is 1.1. And what we're going to do is we're going to find all of the remaining parts of this triangle. So what we essentially need to do on this is we've got 3 things we got to find. We got to find the value of C. We have to find the value of angle alpha and beta. So in a sense, you've been given 3 parts of the triangle because you know it's a right triangle. So what we're going to focus on here now is just getting the values, those 3 left over parts of the triangle, like that. Okay, so let's kind of discuss how you would do this. First of all, if I give you 2 sides and you want to find the third, well, we know the Pythagorean Theorem. So you could start by doing c squared is equal to a squared plus b squared and just plug things in. So a is going to be 3.2 squared. And then b is going to be 1.1, so we're going to go ahead and do that then, okay? I'll kind of display the calculator as I do this. Now, when you're really doing this, you can do this all in one step, so I'm just going to go 3.2 to the second power plus 1.1 to the second power. And I'm just going to record what that is. Okay, so that's, if I go back over here, that's going to give me 11.45 is what the calculator generated. So I'm going to go back and write this out as 11.45. So now what I have is I have c squared equals 11.45. And now remember what you do in this case, if you solve for c, is you take the square root of both sides. And then we're going to get an approximate answer. And what I'm going to do is just round these to 1 decimal place. So what we need to do on the TI now is just do the square root of 11.45. And that's going to give 3.4. So we'll round that to 3.4. And then we'll have that part of the triangle solved. Okay. Now, we haven't done any trigonometry yet, but it turns out you've got to use trigonometry if you're going to do the rest of this now. So we've got kind of that side taken care of now. Now, what we need to do is focus on an angle. We need to just choose an angle. I'm going to choose this angle alpha, and I'm just going to focus on this angle alpha. And I'm going to look at the 2 things I gave you and talk it out. I gave you the side opposite that angle, and I gave you the side adjacent. So by definition, we would know that the tangent of alpha is equal to the side opposite alpha, which is 3.2, over 1.1. Okay, so what we can do now is one of the things we learned in this section is we're trying to find angle alpha. So the way you put this in your calculator now is you got to do the inverse trig function. So you're going to say inverse tangent of 3.2 all over 1.1. And just do this in one step on the calculator. And since I want the answers to be in degrees, you want to be sure again that if you press the mode button that you're in degree mode. Okay, so what we should do now is just go second tangent and then do 3.2 divided by 1.1. Okay, and if you do that, you're going to get an answer of 71 degrees. Let's just round that to 71 degrees, and then that'll take care of angle alpha. So angle alpha, we got, how quickly I forget, 71 degrees as an answer to that problem. Okay, so I'm going to just record angle alpha now as 71. And then we only got one more thing to do, is we got to find beta. Well, beta, alpha and beta add up to 90 degrees, so all you got to do is just do 90 minus 71. And if you work that out, you're going to get 19 degrees. So that means the triangle is now officially solved. Okay? Now, one of the things I want to show you also on here that's kind of a worthwhile thing to do, this we'll get a little bit later into some things that we'll do a little bit later in the semester here, but you can formulate ratios like this. We call this the law of sines, which we'll learn at the end of the semester. So I want to just show you, if I picked an angle, like if I picked 71, if I just did the sine of 71, like that, and then if I divided that by the side opposite, which is 3.2, and then if I picked another angle, like 19 degrees, and I did the sine of 19 degrees, like this, okay, there's 19 degrees, and then if I picked the side opposite that, 1.1, and then if I went to the last angle, which of course is 90 degrees, and if I say sine of 90, and put that over the side opposite, all of these ratios should turn out to be approximately the same. Okay, so what I'm going to do on this is I'm just going to display my calculator, and I'll show you how I crunch these things out then. And I can move this calculator around so I can show you what I'm doing. Okay, so if I go sine 71, let me move this up just a little bit, sine 71, then if I divide that by 3.2, I'll get that value. Now I'm going to go to the next thing, which is sine of 19 degrees, divide that by 1.1, and you get this, okay, which is pretty close to the same answer. Then if I do the sine of 90 and divide that by the opposite side, and you got to close that parenthesis, so you got to be careful about that. Okay, so I'm going to do sine of 90 divided by 3.4. If I do that, I've got almost the same thing. Now you'll notice these things are off a little bit, but they're accurate to 2 decimals. That's because we rounded the angle, so you can use this as a methodology to tell that you're correct on these problems. So that's a nice thing to know. All right, I'm going to go to the next page, and I'm going to do one more, and then I'll give you an opportunity to work on a couple of those and see if you're on the right track now. All right, so as I do this next one, again, it's real important that you draw a triangle. So I'm going to start on this just by drawing the right triangle. Again, it doesn't have to be drawn to scale. It doesn't really make a bit of difference. You do this just to be able to represent your values correctly. Okay. Now, as I go through this, the next thing I'm going to do is I'm just going to label all the parts that I have. So again, the naming convention is alpha and beta are going to be what we call the acute angles. Oh, stop that. I hate it when it does that. So let me erase that. Okay, like that. So we need to get those things done. All right, so this is angle beta right here. Okay, and then this is angle gamma right here. That's the right angle, okay? Angle A, side A is 2.2, so that goes opposite the angle alpha, okay? And then the other thing I gave you on this is I gave you angle alpha as 63.4 degrees. Okay, so what you need to find is on this, I'll just highlight what we need to find. We need to find angle beta, we need to find side C, and we need to find side B. So those are going to be the three things that we're now going to focus on, is finding these things. So side C, remember, is opposite gamma. Then we're going to find angle beta, and then we're going to find side B, which is opposite beta, like that. Okay, so one of the things on this one that you can start with is, that's kind of a key thing, is angle beta and alpha add up to 90 degrees. So if you want to find angle beta, you don't need any trigonometry, you just do 90 minus 64.4 degrees. Okay, so we can go ahead and do that just by hand or by the calculator if we want to. So 90 minus 63.4 degrees is going to be 26.6 degrees. Okay, so now we can fill that out as that angle value, 26.6. All right, so that angle, let's fill that in, 26.6 degrees. So we got that. Now we're down to finding two sides. Okay, we can't use the Pythagorean theorem because you have to know two of the three sides, but we can do trigonometry. So one of the things I tell students to do is use what I gave you. So I gave you alpha, I gave you A. Let's go ahead and let's just start by finding side C. Okay, so if we talk this out, in relation to alpha, I've given an opposite and I've given a hypotenuse. So we're going to use the sine because the sine is the opposite over the hypotenuse. So I'm going to say sine of 63.4 degrees, which I gave you, equals side opposite, 2.2, which I gave you, all over that side C. And then we can solve this proportion. See, this is just a mathematical proportion, so I can put that over 1. Then I can cross multiply. So when I do that, I'll have C times, like this. Come on, stop that, whatever you're doing. C times sine 63.4 is going to be equal to 2.2. Okay, then I can divide both sides of this equation by sine of 63.4, because all that is a numeric value anyway. Then I can go to the calculator, and then that'll give me an approximate value for that then. Okay, so we'll be sure that you're in degree mode. So again, what we're going to do on this is we're just going to go 2.2 divided by, and we're going to do the sine of 63.4. Like that. That'll give about 2.5. So let's round that to 2.5. Okay. All right, so we got that as 2.5. Now we got one more part of the triangle to find, 2.5. Now you can't, whoops, I'm putting that on the wrong place, so don't make that stupid mistake. Let me erase that. Okay, and that's going to go inside C, so that's now 2.5. Okay, all right, so we got that. Now let's find B. Now I'm going to find B by doing trigonometry because that's more what I'm trying to teach you anyway. So if you look at angle alpha, I gave that to you. I gave you a side opposite. And now if we find B, we're finding a side adjacent. So we're going to use the tangent. We're going to say the tangent of 63.4 degrees is going to be equal to the side opposite, 2.2, over the side adjacent B. Then we can cross multiply. Okay, so when I cross multiply, I'm going to have B times the tangent of 63.4 equals 2.2. Okay, I can divide both sides by the tangent of 63.4. Okay, like this. And then I can get my calculator out to get that final value. Okay, so I'm just going to do that on my trusty TI. So 2.2 divided by tangent 63.4 is going to give about 1.1. Okay, so I'm going to approximate that and round that to 1.1. And then our triangle is solved. So we have found all the remaining parts of that triangle. Okay. All right, so hopefully that makes sense. So what I'm going to do is let you work a little bit on this next one. So I'm going to pause my recording and let you go ahead and do that for a little bit. Okay, well, let's go ahead and let's see on this number 21 how we did. So I'm going to start by again drawing a triangle of some sort. A right triangle, like I said, doesn't have to be drawn to scale. But what is important that you label the angles and sides correctly. Okay, so let's go ahead and get these things labeled. I'm just going to do the same thing that I've kind of been doing on all these problems. I'm going to call that alpha. I'm going to call this my beta, and I'm going to call that gamma. That's alpha. That's A, B, C, like that. Now, on this time, I gave you the hypotenuse 4.4, and I gave you the angle 28.3. Okay, so that means that what we're going to need to find is we got to find these things. We have to find side A, we have to find side B, and we have to find angle A. So we want to get kind of focused on doing that. Okay, well, the first thing is that angle alpha and beta add up to 90, so all you should have done on that is just done 90 minus 28.3. So that'll give you the value of alpha. So I'm just going to do that on my calculator. Be lazy. 9 minus 28.3 is 61.7. Okay, so we got that as 61.7 degrees is what you should have got. Okay, now let's go find one of the sides. Okay, now you have to use Trig to do this. Now again, what I try to get students trained to do is to use what I gave you. So I gave you, oh, I hate it when that stupid thing does that. I don't know why it does that either. Okay, I'm going to erase that crap. All right, let's try again. Okay, so let's go through and again look at what I gave you. And please don't move the triangle pen. There we go. I gave you that angle. And I gave you the hypotenuse. Now let's decide what we want. Let's just start with finding side B. You can start with side A. Okay, I gave you the side opposite and I gave you the hypotenuse. So that means we're going to use the sine. So the sine of 28.3 degrees is going to be the side opposite, B, over the hypotenuse, 4.4. So that will be a real simple proportion that we solve. So you just cross multiply. 1 times B is B. Then we need to do 4.4 times the sine of 28.3. Go to the calculator, just probably round 1 decimal. So if I do 4.4 sine 28.3, I'm going to get about 2.1. Okay, like that. All right, so that will be 2.1. That'll give that part of the triangle then. Okay, so that leaves us with one more thing to do. We now got to find A. Now what I'm going to do again is I'm going to look at what I gave you, which is these two things, and what I'm trying to find. So we're trying to find A, so we're looking at adjacent 28.3 and hypotenuse. So the cosine is adjacent over hypotenuse, so we could say cosine of 28.3 degrees is equal to adjacent A over hypotenuse 4.4. Now you could do the Pythagorean Theorem also, now that you know two sides. I find it just as simple to go through and just do trigonometry again. So that's A equals 4.4 cosine 28.3. Just crunch that out on the calculator, and then we'll be done with the problem. 4.4 cosine 28.3, whoops, is going to give 3.9 is what I'm coming up with. All right, so that solves the problem then. One thing I did want to mention about this a little bit too is when you get answers, and I showed you how you can check, but also I want you to see this. Notice the biggest angle is gamma. Well, the biggest side turned out to be C. The smallest angle is 28.3. Notice the smallest side turned out to be opposite that smallest angle. So that's a real logical way to check and verify that you have a correct answer to the problem. Okay? All right, now let's go on and let's look at the next one and see how you did on this one. So again, I'll just draw a right triangle of some sort. That's kind of a weird way to draw it. Let me try this again. Oh, come on, behave. Do what you're supposed to do. Okay, so here's my right triangle. And let me get one more side of that put together. Okay, and again, let's just do kind of the same naming convention that I've been pretty well doing throughout here. So let's do, again, just keep doing it the same, I guess. Let's just call that alpha, call that beta, and call that gamma. This would be side A. This would be side B. That would be side C. So in this particular problem, I gave you two sides. So I gave you A is 3.2. That was a given. Then I gave you B is 1.1. So we're going to go ahead and find the rest of the parts of the triangle like that. Okay, well, one thing you got to do on this one is you got to start with the Pythagorean theorem. So we're going to start with c squared equals a squared plus b squared. So that means c squared is equal to 3.2 squared plus 1.1 squared. Okay, so if we do that, you can crunch this out in one step on your calculator. So you just do 3.2 squared plus 1.1 squared. You're going to get 11.45. You know, I'm having a deja vu experience. I think I already did this problem. Let's go ahead and finish it up anyway. All right, so let's go ahead and do the square root of both sides. So if I do square root of 11.45 now, I'm going to get about 3.4. Okay, so that will give us C 3.4, round to one decimal. Okay, so that takes care of that. So we got that. Now we're ready to find an angle. Now again, what I'm going to do is just say, okay, I'm going to pick alpha, and I'm going to use what I gave you. I gave you the side opposite and the side adjacent. So what that is that's the tangent. So I'll say tangent of alpha is equal to opposite 3.2 over 1.1. When you do this, alpha, you got to use the inverse tangent. So you say inverse tangent on your calculator of 3.2 over 1.1 like that. Okay, I'll just pull up my emulator on that then. And again, it's second. It might help if I turn the calculator on. There we go. So we go second tangent, 3.2 divided by 1.1. And then that'll give about 71 degrees. Okay, so we got alpha is about 71 degrees. Okay, now you don't have to do trig again. You know, all you're going to do to get beta is 90 minus 71. So that's going to be a 19-degree angle like that. Okay, so that's how that goes. Hopefully you got that figured out okay. The whole key is the naming convention of the triangles, and then you have to be solid with your definitions of your trig functions as well. Okay, now to move on, what I'm going to do on this next page here is I'm going to look at just some applications, and this will give you a pretty good idea of how we use trigonometry out in the field. So the first thing I want to pay attention to is if you were on the ground and you were looking up at something, like say you're looking at this hot air balloon, the angle of elevation is just going to be from the ground to whatever you're looking at. So we're going to call that angle of elevation. So it kind of works like this. Here is your eyeball. That's a pretty crappy eyeball. Put a few eyelashes on it. So if you're looking like parallel to the ground, we call that the line of sight. And if you're looking at something, like if you're looking at the sun, hopefully you don't look directly in the sun to damage your eyes. But if you did, that would be your angle of elevation like that. We'd call that theta or alpha, okay? Angle of depression is shown by this diagram. So it means, okay, now you're up in the balloon. Now you're looking at a pot of gold down on the ground, or a money bag or something. So you're looking at this angle like this. So you're looking at your line of sight. So see, this thing right here is parallel to the ground. So you're looking down like that. So again, this looks like this. Here's your eyeball. There's your beautiful eyelashes. And now you're looking down, you're looking parallel to the ground. That's called your horizontal line of sight. Now say you're looking down at something, then that is your angle alpha, that's your angle of depression. So it's important to know what the difference between those two things is then, okay? Now what we're going to do is we're going to work some of these problems out. Part of the biggest challenge of these problems is trying to go through and draw diagrams on this. So this problem right here says, from a boat on the lake, the angle of elevation to the top of the cliff is 30 degrees 56 minutes. If the base of the cliff is 127 feet from the boat, how high is the cliff? Okay, well, let's first of all just kind of draw a straight line, and we'll say for all practical purposes that's our cliff. Okay, then we'll say, okay, this is the lake, like that. You got your boat on your lake, so here's your boat. Okay, you're sailing away and enjoying the day. And what you're doing is you're looking up at the top of the cliff. Now, for all practical purposes, let's just say that your line of sight is parallel. Now, what the heck is this thing doing? Okay, come on, just draw a line the way I want you to. There we go. Okay, so we got a line like that. And then that's going to be your angle of elevation that the word problem says is 30 degrees 56 minutes, like that. Okay, now it says the base of the cliff is 127 feet from the boat. So here's the base of the cliff. Here's the boat. So that means that this side of the triangle is going to be 127 feet. All right, now the question in this problem is, how high is the cliff? So we're going to call that x. Now, for all practical purposes, we just assume this is a right angle. So now if you look at what you were given, so I've given you this angle, we're finding the side opposite, and I gave you the side adjacent. So that means we're going to use the tangent. Opposite over adjacent is the tangent, so we say the tangent of 30 degrees 56 minutes is equal to opposite, which is x, over 127. Okay, like that. Right, now this is a proportion, so we cross multiply it. So x times 1 is x. Okay, then we're going to do 127 multiplied by the tangent of 30 degrees 56 minutes, like that. So let me pull up the calculator here so you can see this okay. And I'll show you how I put this in like this. So when I put this in the calculator, I want to go 127. You also want to turn the calculator on first. Don't forget to do that. That's important. So we have 127 tangent. And see, I just go 30 plus 56 over 60 like we learned, and I find that to be just as quick to do it like that. And then you got your answer. Your problem is about 76.1 feet, like that. So the problem is now solved. Okay, so we get about 76.1 feet is our final answer to that problem. Okay, I do want to show you one other thing on this calculator, because you can also go like this. You can also go 127. Now, you don't have to put the time symbol in there, but you could. Tangent, and then you can also go like this, 76. You can go second apps to get the angle command to come up, and then just highlight the degrees. Then you can put in the, oh wait, I'm putting in the wrong angle, so let's back up and go over that then. So that's going to be 30 degrees, like that. Okay, and then we put in the 56. Then you can go second apps, and then go down to the minute mark, and go like that. Okay, you can do it that way too if you want to, but to me it takes more time to find all your buttons and press all those keystrokes, so I don't ever do it that way. Okay, so let's go to the next page, and let's look at a couple other things. This next problem, what I want to look at on this next problem is, okay, you have a balloon that is a certain distance high. So let's draw our hot air balloon. Wouldn't you like to ride in my beautiful balloon? Do you guys know what that song is from the 1960s? Probably not. Okay, let's see. 1,024 is, we're going to say, okay, that's how high the balloon is. 1,024 feet. Okay. Then it says you're looking at a ranger headquarters. So this is your ranger headquarters down here. Okay, you're up here. And for all practical purposes, let's just say that your line of sight, your horizontal line of sight, we call that, would be parallel to the ground, like this. So this is going to give the base of the triangle like that. And then you're looking down at that ranger headquarters like this. So this would be your angle of depression, which is going to be given by 88 degrees 17 minutes. Okay. And then the other thing that we're going to find is it says how far is the headquarters, which is here, from a point on the ground below the balloon, which is here. So you're trying to find that base of the right triangle like that. Okay, one thing that you learn in geometry is if you have two parallel lines and you slice those two parallel lines, like if this angle was 70, that angle would also be 70. Those are called alternate interior angles, and alternate interior angles are always congruent. So you utilize this a little bit on these problems like this. So this angle that I'm showing there is an alternate interior angle, so it's the same thing. Okay, now if we set this up, just kind of talk out what we have. That's the angle. This is the side opposite. I'm wanting the side adjacent, so it's the tangent again. Opposite over adjacent is the tangent. So what we're going to say is the tangent of the angle that I gave you, 88 degrees 17 minutes, is equal to opposite 1024 over the side adjacent x. Then we just need to solve that like this, okay? Now, there's a couple of things you can do on this too, but if you want to, you can actually, when you have a proportion, you can turn both things upside down. I'm going to show this just for purpose of variety here, so I'd have this. I don't know why I'd do this, but it's just something you could do. Now, if you were to cross multiply that, you would have x tangent 88 degrees, 17 minutes, is equal to 1024. Then we could divide both sides by the tangent of 88 degrees 17 minutes. And then we would be able to get our calculator out and get that answer. Okay, so that'll cancel out. This will give us the value of x, and then we'll round that. So I'm just going to take 1024, divide by tangent 88, and I'm going to go plus 17 over 60, like the last problem. So that gives about 30.7 feet then. Okay, is what you're going to get there. All right, and then I'll just round that off, and 30.7 feet is going to be the final answer to that problem then. Okay? Okay, the next problem. If you look at the next problem, it's got a very similar scenario. It's not much different on that. So I would like to have you all go ahead and just try to work out this last problem yourself. Go ahead and just pause the recording on this, and then you can resume as soon as you're done. Okay, so let's see what we came up with here then. Okay, so we have a tree. There's my tree. Every time I draw a tree, I think of that artist Bob Ross. Bob Ross, do a Google search on him. He's got this big afro, a great painter, but every time he draws a tree, he calls it a happy little tree. So I just drew a happy little tree, and then it says Mac is on top of this tree for whatever reason, who knows why. But anyway, he's looking down at his buddy Joey, who's on the floor, who's on the ground, and let's see, it says Joey is 10 feet from the base of the tree. Okay, so we know this part right here is going to be 10 feet. And that'll represent that base of the triangle like that. And then we got old Mac. So Mac he's got his horizontal line of sight, which is parallel to the ground. And then he's looking down at his good buddy Joey, who's probably picking his nose or something. And that means the angle of depression is 43 degrees, 4 minutes like that. Now, that also means that this is 43 degrees, 4 minutes. So now we're ready to solve the problem. So what we're trying to do is we're trying to find the height of the tree. I'll call that h for height. So if you look at your right triangle, we assume that the tree's at a right angle. That's, I hate it when it does that. Stop that crap. Okay, so if we go through and do this, okay, what we have is we have this angle. Again, I gave opposite over adjacent, so it's going to be tangent again. It can be all kinds of different things. Just kind of coincidentally, all these problems have dealt with the tangent. So we're going to say tangent of 43 degrees, 4 minutes, is equal to the side opposite h over the side adjacent 10. Okay, then it's just kind of a matter of cross multiplying that. So you have h times 1 is h. Then you have 10 times tangent of 43 degrees, 4 minutes. Okay, you can put that in your calculator. and get the answer on that. So I'm just going to put this in. I'll show my emulator one more time just in case you need to see that. So again, we're going to go 10. We're going to turn the calculator on, Brad. Then 10, and then tangent, and then we'll do 43 plus 4 out of 60. That way it's converting that to decimal degrees automatically. Okay, so it's about 9.3 would be the answer of the problem. Okay, and then that will finish this up. That will be the end of this. This is really a long section. It's got a lot of information in it. It is a section that you'll begin to see the practicality of trigonometry. Trigonometry really developed originally from triangles, and really all the construction problems and stuff like that, where people needed to figure angles and sides out. That's where it came from. It was very big in navigation in the 1500s, and trigonometry's been around for quite a long time, so you'll see the application. Okay, hope you enjoyed the presentation, and hope this will help you to learn this material well. Thank you for watching.